variation. So we'll be looking at stuff with direct variation, like direct variation as a power, inverse variation, and joint variation. And all those things that you should have in your notes have formulas that are associated with them. So we are going to look at just like one little section of problems. That's this stuff, and that's all we have out of this section. So number 8, it just says to solve each problem. If y varies directly as x and y equals 9 when x equals 30, find y when x equals 40. So this is varies directly, so this is going to be a direct variation problem. So the formula for that is y equals kx. If you had Algebra 2 last year, you may remember it. They would say y equals ax. Was typically what they used. It really doesn't matter. It's just like a placeholder, A or K. So we are going to plug in the initial numbers they gave us for x and y to find k, and then we're going to use k and x to find y at the new value. So 9 equals k times 30. So then we divide 9 by 30, so 9 over 30 will reduce to 3 over 10, which is k. So that's the initial k value, but I'm not done yet. I need to use that and 40 to find y, so I use y equals 3 over 10 times 40. 10 and 40 cancel, or like reduce to 4. 4 times 3 is 12, so y equals 12 when x equals 40. So that's the answer that they're looking for on that one. Let's see, 10. If maybe m varies jointly as z and p, and m equals 10 when z equals 2 and p equals 7.5. Find m when z equals 6 and p equals 9. So a lot more going on with this one. The formula for joint variation, they're using some different numbers than your formula used in the notes. But the formula in the notes was y equals k x to the n z to the m. But none of these things are being like raised to a power, so the powers are kind of just going to go away. But find m when z equals 6 and p equals 9, since it says, excuse me, since m varies jointly as z and p, that means that z and p are replacing x and z over here, and y is actually going to be m in this case. So my formula for this problem specifically is going to be m equals k times z times p. So we're going to need to solve for k first like we did in the last one, and then we're going to use that to solve for m. So basically all of these problems have like 2 steps that we're doing for them. So m is 10, k we don't know, z is 2, and p is 7.5. So 2 times 7.5 is, what is that, 15? So 15k equals 10. So then divide by that. K is it's gonna reduce to 2/3 is equal to K. And I would recommend just leaving them as fractions because I've done them as decimals and like you're still gonna get to the right answer, but obviously it's easier to, I think it's easier to work with fractions, knowing that things are gonna probably cancel. So this is the K value. So now I'm gonna use this exact same formula, but I'm solving for M this time. So I'm just gonna plug everything in over here. So M equals 2/3 times 6 times 9. So 3 goes into 6 2 times. So I have 2 times 2 times 9. So M equals 36. Any questions on that one? All right, let's see, 12. If y varies inversely, as x and y equals 20 when x equals 1/4, find y when x equals 15. So this one is inverse variation. So the formula for inverse variation involves a fraction. Anytime you hear inverse, you should think of like a fraction or 1 over something. Typically, so the formula for this one is y equals k over x to the n. Now, this is all, anytime that it's like the raised to the n or whatever, like the last problem had, that it will like tell you. So like one of the problems later on says something about like something varies directly as the square of, and it tells you like a letter, or it will say something like let a be directly proportional to m and n squared. So it like tells you like already what those powers are. So you're not sitting there like guessing when you have a power, it's gonna tell you. So this one doesn't actually need the n though. I don't have anything about a power, so I can just get rid of that. So first I've got to solve for k, like I've been doing in all the other ones. So 20 equals k over 1/4. So when I divide by a fraction, I multiply by the reciprocal. So this is really 20 equals 4 times k, because 1/4 would just flip to 4. So divide by 4, so 5 is equal to k. So I'm going to use this number. I can focus this back in. And then I'm going to plug in and solve for y now. So y equals 5 over 15, or y equals 1/3. And that's your final on that one. All right, so let's look at one that involves squares and stuff. So 14. And I would say like the hardest part of these problems is just like picking the right formula and making sure you know what's what. So like make sure you go over those and know those. 14 says, suppose p varies directly as the square of z and inversely as r if p equals 32 over 5 when z equals 4 and r equals 10. Find r, nope, I read the, hold on. Wait, find p, there we go. When z equals 3 and r equals 32. All right, so this one actually combines two different things. It varies directly and inversely, okay? So it says P varies directly as the square of Z. So that means that, in this case, Z is going to be squared. But it's going to be P equals and then this stuff. Now, I've got to put that K in there. Even on an inversely, which is the one we just did, K goes on top, okay? So it's going to be K times Z squared for the directly part over R for the inversely part, okay? So it kind of just like pairs the stuff together. So we've got P equals K times Z squared over R. Got to solve for K first, just like I did in the other ones. So P is 32 over 5 equals K times Z is 4, and that's being squared over 10. So I'm going to go ahead and multiply the other side by 10. So the 10 and the 5, well, here, let's do this. Multiply by 10. So that's going to reduce to a 2 times 32 is going to be 64 equals K times 4 squared is 16. And then divide by 16. So 4 equals K. Now I'm going to use that to set up the other ones. So P equals 4 times 3 squared over 32. So P equals 4 times 9 over 36. Nope, over 32. So 36 over 32 reduces to, what's that, 9 over 8. So a little more involved, a few more steps, obviously, mathematically, when it's like multiple things happening at the same time. But not too bad. Any questions on this? Cool. All right, well, that's all that's in this section. So your problems are, I don't want to say that's all that's in this section. That's all we're doing out of this section. 7 through 15 odd. So that should give you at least one of each type, and then also one or two that like combine two different types together.